Primary valency is non-directional, secondary valency is directional. Ions or molecule attached to the satisfied secondary valency have characteristic spatial arrangement. The pairing of unpaired electron not takes place against Hund's rule because fluorido is a weak ligand. Therefore, they are not vacant. 4d orbitals for hybridization, it is called as high spin complex or outer orbital complex. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidyashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to 4th session of chapter Coordination Compound. 4th session of chapter Coordination Compound. In the previous session, I discussed about isomerism in coordination compound like stereoisomerism and structural isomerism. I discussed about stereoisomerism and structural isomerism. This session, I am going to deal with theories of coordination compound. The first theory is Werner's theory. First theory is Werner's theory. Second one is VBT, that is valence bond theory. In this session, I am going to discuss with two types of theories like Werner's theory as well as valence bond theory. First theory, Werner's theory. Alfred Werner is called as father of coordination chemistry. Father of coordination chemistry. He had given about certain postulates about coordination compound. What are the main postulates of coordination compound? When you consider central metal ion present in a coordination compound, it shows two types of valency. One is primary valency and secondary valency. What are the two types of valency shown by central metal ion? The two types of valency shown by central metal ion are first one primary valency and secondary valency. Primary valency are ionizable, secondary valency are non-ionizable. Primary valency are ionizable, secondary valency is non-ionizable. What is primary valency? Primary valency is the oxidation state of central metal atom or central metal ion. In the IUPAC nomenclature, my dear student, already I discussed before writing IUPAC name of any coordination compound, but to find out oxidation state of central metal atom or ion. Nanali IUPAC name ಮಾಡಬೇಕಾದ್ರೆ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಬಹುದು ಪ್ರತಿ ಸರಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ಗೂ ಅಯಾನ್ಗೂ ಎಕ್ಸ್ ಅಂತ ಹಾಕೊಂಡು ಅದ್ರದ್ದು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಕಂಡಿಡಿದೆ. ಆ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರೇ ಪ್ರೈಮರಿ ವೇಲೆನ್ಸಿ. Secondary valency is nothing but its coordination number. What is coordination number? It is the total number of ligands formed between central metal atom or ion as well as ligand. Therefore, first postulate of Werner's theory is central metal atom or ion show two types of valency, primary valency and secondary valency. The primary valencies are ionizable satisfied by negative valency. Secondary valency is non-ionizable. It is equal to the coordination number of the metal atom. It is fixed to a metal. Secondary valencies are satisfied by negative ions or by ligand. The secondary valency is satisfied by negative ions or by ligand. Primary valency is non-directional. Secondary valency is directional. Ions or molecule attached to the satisfied secondary valency have characteristic spatial arrangement. Secondary valency decides the geometry of the complex. Secondary valency decides geometry of the complex. For example, it is X and it is 0. Because of this is 3 minus and it is 3 plus. X plus 0 is equal to 3. Therefore, primary valency is 3 and secondary valency, it is the number of unit interligands are 6. Therefore, coordination number is 6. Primary valency is exhibited by 6 Na3 ligand. Secondary valency is by 3 Cl minus ligand. Geometry is octahedral. Geometry is octahedral. Why geometry is octahedral? Because its coordination number is 6. Coordination number is 6. Why this theories get failure? Because it does not explain the property of coordination compound, and the bond formation in coordination compounds have directional properties, and coordination compound, it does not explain about magnetic property and optical property. The magnetic and optical properties of coordination compound cannot be explained by Werner's theory. Cannot be explained by Werner's theory. Therefore, second theory was proposed is called as VBT, valence bond theory. So, metal atom or ion under the influence of ligand can use its N-1d, NsNp or NsNp orbital for hybridization to yield a set of equivalent orbitals of definite geometry such as octahedral, tetrahedral, square planar. These orbitals are allowed to overlap with ligand orbitals that donate electron pair for bonding. It is usually possible to predict the geometry of the complex by the knowledge of hybridization as well as magnetic behavior. If the coordination number is 4, sometime it is sp3 hybridization, sometime it is dsp2. When it is sp3 hybridization, geometry is tetrahedral, dsp2 square planar, 5 sp3d trigonal bipyramidal, 6 sp3d2 and d2 sp3, geometry is octahedral, geometry is octahedral. Now you have to find out the inner orbital or low spin complex of hexaamine cobalt 3 ion. Oxidation state of cobalt is +3, has the electronic configuration 3d6. Cobalt is Ar 3d7 4s2, 3 plus andre we have to remove this 0, Ar 3d6 4s0. If I write in the orbital 3d6 according to Hund's rule, 4s 4p 4d. So during when 3 amine ligands approaches, the pairing of electron takes place against Hund's rule. So they start to get paired and 2 empty 3d orbital 4s and 4p undergo hybridization to form D2 sp3 hybridization, D2 sp3 hybridization. Therefore 6 orbitals which are vacant, these 6 pairs of electron donated by ammonia. Here the colored arrow marks are the electrons which are donated by amine ligand. Observe here all the orbitals are completely filled, therefore it is diamagnetic, it does not have unpaired electron, and 6 ligands are there, as well as the geometry is hybridization in D2 sp3. It is octahedral. It is octahedral. Okay. Next, I'll change amine by fluorine. So, what is the oxidation state? +3. Once again, it will become Ar 4s0 3d6. When I write electronic configuration according to Hund's rule, first 1 electron to each box. Next, here the pairing of unpaired electron not takes place against Hund's rule because fluorido is a weak ligand. Therefore, they are not vacant. Therefore, it 1 4s vacant orbital 4p3d. This undergo hybridization. It will form sp3d, it will form sp3d2 hybridization, sp3d2 hybridization. So these vacant orbitals, 6 fluorido ligand donate electron and it is filled. Observe it has 4 unpaired electron, therefore it is paramagnetic and octahedral geometry. And there is an involvement of 4d electron, 4d orbitals for hybridization. It is called as high spin complex or outer orbital complex. If 3d orbital is involving, it is low spin complex or inner orbital complex. 4d orbital is involved, it is called as high spin complex or outer orbital complex. Next, tetrachloridonickelate 2 ion. Oxidation state of nickel is +2. Therefore, electronic configuration nickel is Ar 3d8 4s2. In 2 plus, it will become Ar 4s0 3d8. If I write configuration 3d8, first 1 electron to each box, next 1 electron to first 3 box. So, spin pairing takes place. So, no spin pairing in place because chlorido is a weak ligand. Therefore, 1s and 3p orbital, it undergo sp3 hybridization. Here, unpaired electron, therefore it is paramagnetic. Because of sp3, it is tetrahedral. Because it is sp3, it is tetrahedral. Next, chlorido is replaced by cyanoido. Once again, nickel is +2 oxidation state. It will become Ar 4s0 3d8. I'll fill this 3d by Hund's rule. 1 electron to each box, next first 3 by 1, 3d, 4s and 4p. Because cyanide is a strong ligand, here spin pairing takes place, 1d vacant, dsp2 hybridization and 4 sp2, dsp2 hybrid orbital, 4 cyanide ligand donate electron and here all the electrons are paired up, therefore it is diamagnetic. Because of dsp2, it is square planar structure, Therefore, so I had discussed about the geometry as well as structure of CONA3, hexaamine cobalt 3 ion, hexafluorido cobalt 3 ion and tetrachloridonickelate 2 ion and tetracyanidonickellate 2 ion. How it is paramagnetic and how it is diamagnetic. If it contain unpaired electron, it is paramagnetic. If it does not contain unpaired electron, it is diamagnetic. If 3d electrons are involved, it is called as inner orbital complex or low spin complex. 4d electrons are involved, it is called as high spin complex or outer orbital complex. So today in this session I completed Werner's theory as well as what? VBT. In the next session I will come up with one more theory, that is CFT, as well as magnetic properties of coordination compound. Next session I will come up with a new theory, that is called as CFT as well as magnetic property. Until then, goodbye, take care, thank you.